You might look at this question and think to yourself, hey, that's a good point. What gives? Why would it stop moving if momentum is conserved? Is physics fake? And well, all of those are very valid questions. But there is an explanation for this, fear not. Now, generally, in most examples, when we talk about momentum being conserved, or when we talk about collisions, usually those are in examples where we're looking at just those objects, where there are no other forces outside forces affecting it. Or like when we talk about when atoms are colliding or something like that. Usually those atoms are just acting independently. Or sometimes when you talk about a car, for instance, when there is a car crash, and we examine its final velocity just before the moment of collision, and how that compares to immediately after the collision. But yes, in many practical cases, there will also be forces acting against it. Um, for example, if a car is being driven at a constant velocity or speed of so-and-so miles per hour, and someone's keeping it that way, then despite the rolling friction of the ground and the air resistance from the air acting against it, there is a constant force being applied from the motor and the engine inside that keeps acting on it. But if the car was coasting, if no one was actually applying the gas pedal, then eventually that rolling friction from the wheels would act against the car. But again, the conservation of momentum theorem, or law, I should say, isn't something that, like, on its own takes into account outside forces, because it's just about momentum. Now, if you were talking about an example where, say, there was a box on a table or something, sliding down the road, sliding down a table, and the friction acting against the box was causing it to slow down, and the box itself is losing momentum. But if your reference frame was including the table, then overall that momentum or that energy is not disappearing. It's just being transferred over to the table. So that is why that is the answer to this question. Because when there are outside forces acting on it, it's going to take away that momentum of the other objects.